GeopByte.
Welcome to GeopByte. Hi students, in the previous video we have covered the topics operations on real numbers and example problems from 12 to 16 and identities of square roots. In this video, let us cover the topics example problems from 17 to 20 and the first question in exercise number 1.5. Now, let us see example number 17. Rationalize the denominator of 1 by root 2. See, we know that we should not have irrational numbers in the denominators. So, let us rationalize the denominator of 1 by root 2. That is, we need to rationalize the denominator root 2. See, we have 1 by root 2. Now, in order to rationalize, we need to multiply and divide with root 2. See, for 1 by root 2, let us multiply and divide. Multiplying and dividing root 2 for 1 by root 2. Now what it becomes? 1 into root 2, root 2 by root 2 into root 2 means root 2 whole square. So square and root gets cancelled. Root 2 by 2. Right? Only 2 is left in the denominator. So root 2 by 2. We rationalized the denominator of 1 by root 2 and got root 2 by 2. Now, let us see example number 18. Rationalize the denominator 1 by 2 plus root 3. See, we all know that 2 plus root 3 is an irrational number. We need to rationalize the denominator, that is, we need to rationalize 2 plus root 3. See, the given question is 1 by 2 plus root 3. See, by seeing this denominator, we can write this identity that a plus root b into a minus root b is equal to a square minus b. We remember this identity, right? A plus root b into a minus root b is equal to a square minus b. See, here we have 2 plus root 3. It is in the form of a plus root b. We have a plus root b here. The remaining one is a minus root b. So, here a is equal to 2, b is equal to 3. So, we have the positive one. So, now in order to get the negative one, let us multiply and divide 2 minus root 3 by 2 minus root 3. See, already we have the plus sign. In order to get this identity, we need to have a minus sign. That is why I have multiplied and divided with 2 minus root 3. Now let us multiply the numerators and denominators. 1 into 2 minus root 3 is nothing but 2 minus root 3 by, see, if you see this, it is in the form of a plus root b into a minus root b. So, a plus root b into a minus root b is equal to a square minus b. What is a? 2. So, 2 square minus b. b is nothing but 3. Now, 2 minus root 3 by 2 square is nothing but 4 minus 3. As you all know, 4 minus 3 is 1. So, 2 minus root 3 by 1 is equal to 2 minus root 3. If you see 1 is a rational number. So we have rationalized the denominator 2 plus root 3 into 1. Now let us see example number 19. Rationalize the denominator of 5 by root 3 minus root 5. As similar to the previous case, we need to rationalize the irrational number. See, let us write the given question. 5 by root 3 minus root 5. See, we need to rationalize. We have irrational number in the denominator. So, by seeing this, yes, we can write the identity root A plus root B into root A minus root B is equal to A minus B. This identity is in the form of A plus B into A minus B is equal to A square minus B square. Since we have roots, we don't have squares. So, now we have root 3 minus root 5. That is nothing but it is in the form of root A minus root B. We want root A plus root B, that is, see here, A is equal to 3, B is equal to 5. According to this, A is equal to 3, B is equal to 5. Now as we have the minus sign already, we need to multiply and divide with root 3 plus root 5 by root 3 plus root 5. Right? As we have minus sign already, we have divided and multiplied with the plus sign. Now, let us multiply the numerators and denominators. 5 into root 3 plus root 5. And in the denominator, it is in the form of that identity, that is root A minus root B into root A plus root B. It gives you A minus B. What is A? 3. What is B? 5. So 3 minus 5. Now let us write the next step. 5 into root 3 plus root 5 by 3 minus 5 is minus 2. Now see, this can be written as minus 5 by 2 and root 3 plus root 5. Right? We have separated minus 5 by 2 and into root 3 plus root 5. Now the denominator is rationalized. Now let us see example number 20. Rationalize the denominator 1 by 7 plus 3 root 2. We all know that 7 plus 3 root 2 is an irrational number. So we need to rationalize. First let us write the given question. 1 by 7 plus 3 root 2. Now see, this is in the form of A plus root B. We have the identity A plus root B into A minus root B is equal to A square minus B. Right? So it is similar to this identity. We have the positive sign in between. So we need to multiply and divide with the negative sign in between, that is 7 minus 3 root 2 by 7 minus 3 root 2. Right? See, here this is A minus root B. This 3 is just multiplied with the root 2. We will solve them. First, let us multiply the numerators and denominators. 1 into 7 minus 3 root 2 is nothing but 7 minus 3 root 2 by, see, this is in the form of that identity a plus root b into a minus root b. The answer is a square minus b. Here we have a as 7, b as 2. Now if you see, a square minus b means 7 square minus, see, in the place of b we have root 2 and also 3. So we should write 3 root 2 whole square first. Right? So wait, this can be clearly explained by 7 plus 3 root 2 into 7 minus 3 root 2. Right, now let us solve. First 7 we need to multiply this and this, that is 7 sevens are 49 minus 7 threes are 21 and we have root 2, so 21 root 2 plus 7 threes are 21, we have root 2, let us write root 2. Right, I have multiplied this, now I need to multiply this, plus 3 root 2 into minus 3 root 2, that is nothing but 3 threes are 9. Root 2 into root 2, it is 2. See, we have plus into minus, so it is minus. Right? Plus into minus minus, 3 threes are 9. Root 2 into root 2 gave you 2. Now 49, this minus 21 root 2 plus 21 root 2 gets cancelled. Now what is left? 9 into 2. So 49 minus 9 2s are 18. So now 49 minus 18 gives you 31. If you see here, see, this next step is 7 minus 3 root 2 by 7 square is nothing but 49. 7 sevens are 49 minus, this can be written as 3 square is nothing but 3 threes are 9 into again root 2 whole square, means we are dividing this as 3 square into root 2 whole square. As this is whole square, it comes for the both numbers. So 3 square into root 2 whole square. As per this, 3 square is nothing but 9 into root 2 square is nothing but square and root gets cancelled into 2, that is 7 minus 3 root 2 by 49 minus 9 2s are 18. We got the same. So 7 minus 3 root 2 by 49 minus 18 is nothing but 31. We got a rational number in the denominator. So we have rationalized the denominator. Now let us see exercise number 1.5. In that, the first question is classify the following numbers as rational or irrational. See, we have the first question as 2 minus root 5. To check whether it is a rational or irrational number, first let us write the value of root 5. Root 5 value is 2.2360679 and so on. Now let us substitute this in this. See, by seeing root 5 value itself, we can say that it is non-terminating, non-recurring. See, non-terminating and non-recurring decimal. So if we substitute in root 5's place, we get 2.2360679 and so on, gives you 2 minus 2.2 2360679 and so on gives you minus 0.2360679. So, by seeing the answer itself, we can say that it is a non-terminating and non-recurring decimal which is an irrational number. Let us write 2 minus root 5 is a non-terminating and non-recurring decimal. So, it is an irrational number. Now let us see the second one. We have 3 plus under root 23 minus under root 23. See, now let us write without brackets 3 plus under root 23 minus under root 23. I have removed the brackets and written. Now if you see plus root 23 minus root 23 gets cancelled. The leftover number is 3. As you all know, 3 is a rational number. Now, let us see third one. We have 2 root 7 by 7 root 7. See, let us write the given question. 2 root 7 by 7 root 7. If you see here, we have root 7 in the numerator as well as in the denominator. Obviously, they get cancelled. Now, what is left over? 2 by 7. Right? You know the definition of a rational number, right? Which is in the form of P by Q, where P and Q are integers and Q not equal to 0. So here also it is in the form of P by Q, where P and Q are integers and Q not equal to 0. That is, we have 7 here. So 2 by 7 is a rational number. Now let us see fourth one. We have 1 by root 2. See, we know that we need to multiply and divide with root 2 as we have seen the example problems. In that we have multiplied root 2 and root 2, right? Divided with root 2. So now let us multiply the numerators and denominators. Root 2 into 1, root 2 by root 2 into root 2 means root 2 whole square. Square and roots get cancelled, so 2 is left over. It is nothing but root 2 by 2. Now if you see, the value of root 2 by 2 will be 0.7071. So and so on. Now by seeing this itself, we can say that it is an irrational number because it is non-terminating and non-recurring. So root 2 by 2 is non-terminating and non-recurring decimal. That is, we got the value of this as 0.7071 and so on. So root 2 by 2 is an irrational number. Right? Now let us see fifth one. We have 2 pi. Right? By seeing the pi itself, we can say that it is an irrational number. But let us solve. Pi is equal to 3.1415 and so on. Then 2 pi becomes, that is nothing but 2 into pi, 6.2830 and so on. So this decimal is also non-terminating, non-recurring. 6.2830 is non-terminating and non-recurring decimal. So 2 pi is an irrational number. The remaining topics will be covered in the next video. You are welcome to contact us on Telegram to clarify your doubts regarding these topics. Check out the link in the description. Thank you for watching. Please do like, share, comment and subscribe to GeopByte.
GeopByte.